Okay, now next it's time to evaluate this following limit. So the limit when x goes to 1 of the cubed root of x minus 1 over the 7th root of x minus 1. So when we just plug 1 and always do what we always plug the value that we want to compute, so we get 0 over 0. Okay, so we can't decide because this is an undetermined form. Okay, we can use the conjugate, yes, but the conjugate is gonna be a lot of work, especially if one needs to know the like x cubed minus 1 is it's x minus 1 times x squared plus x plus 1, and x to the power 7 minus 1 is x minus 1 times x power 6 plus x to the power 5 plus x to the power 4 plus x to the power 3 plus x to the power 2 plus x plus 1. Okay, so we need to know all this. In general, we have x minus 1, x to the power n minus 1 is x minus 1 times the sum of x to the power k going from 1 to n minus 1. Okay, so this is just, the sigma is just saying that we're going to take the powers, we're going to sum the powers of x with the power k going from 1 to n minus 1. Like here, the power is going to go from 1 to n minus 1, which n is 7 here, so n minus 1 is 6, 7 minus 1, which is 6. The same thing here. So this is true in general. So we need to remember this one. So we're going to use this one here, and we're going to do both of them, both of these two. So the best way is we define a new variable. Okay, let's call that variable x to the power, x is y to the power 21. Why are we doing this? Because this function with the x to the power, the 7th root of x and the 3rd root of x, they act the same except they are bijective. So except that the values change, so they are like, they look the same. Okay, so this is x to the power 3, so this is x to the power 7. Okay, x to the power 21 is gonna go more. Okay, so the behavior is still the same. They still behave the same. And also we choose this one to kill these two beasts, the one in the front, the one up and the one down. So once we do that, we know that the cubed root of x can be written as x to the power 3. Okay, when you take x to the power 3, okay, and you do it here, you get what? Okay, so let's see what we get here. I get some new light. Okay, so once we do that, we get the limit. The limit is still the same. When x goes to 1, y goes to 1. So the limit. Okay, here we get x to the power 7 minus 1 over x to the power 3 minus 1. You see it from here. So when we take x to the power 1/3, it's y to the power 21 over 3, which is y to the power 7. Okay, the same thing here. The 7th root of x is going to be x to 1 over 7, which is going to be y 21 over 7. It's 3. So here I put x. It's the same. X and y, they're just variable, silent variable, doesn't matter. So now I'm going to use this fact here. Okay, so when I use this fact, I'm going to cancel by x minus 1. Okay, so when you write this one, you're going to write the limit as x goes to 1 of x minus 1, x to the power 6 plus x to the power 5 plus x to the power 4 plus x to the power 3 plus x squared plus x plus 1, everything over x minus 1 times x squared plus x plus 1. So I'm going to use this one because it's different from 0. because it's not equal to 1. It get close to 1. So this number is different from 0. So we're going to use it to cancel. And when I plug 1, nothing is going to be a problem. So I get 1 plus 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 1 over 1 plus 1 plus 1 plus 1. So it's going to be 7 over 3. So, and this is my limit. Okay, so we have proven that the limit of as x goes to 1. So this technique is used to kill this one and this one. We can use another method. We can just get rid of this power here and get rid of this power. But doing this change of variable, we're gonna get rid of this power here and the power in the top, and we get the limit is 7 over 3. Okay, thank you very much. If you see any error, please contact me or put them in the comment section. Subscribe and share. We need more people. We need more people to watch these videos and help us get this channel bigger. Thank you.